want me to do this assignment?
I would like to go through whenever you Okay. So you had an assignment due. It was a major entities assignment. If you weren't here, it would be pretty hard to do it because you wouldn't have been given the assignment. But if you were here, that assignment is due today. I would like you to hand it in if you're done. If you're not done, then you can show up. Not at Flexmore because I have connections. You can show up at lunch tomorrow or something like that, and we can work through it, or you can do it tonight or whatever. But that major entities assignment is due today. So go ahead.
Oh, major.
Yeah, major entities, not the major assignment. Yeah, that's fine. Yep. Okay with that.
You got that? The other assignment was due.
Because it looks big aesthetic.
Okay, so we're kind of done for major entities for a while. That's the last we'll really see of it for a little bit. But we'll come back to it later on when we do our chemical analysis unit. And like I said, we deal with major entities almost every single day for half of Chem 30, so it's important for us to know. What I would like to worry about now is concentration. Yeah, I handed out these notes, right?
Yeah.
Yes, good. Hey, so let's think about this. Concentration is just a way of representing what is the ratio of the solute to the solvent. That's all it is. And so I want to bring your attention to the last time you made iced tea. Somebody tell me, how do you make iced tea?
My grandma was making it.
With ice and tea. No, definitely not. How do you, Cassidy, how do you make iced tea? You take water, powder, and a spoon, and you toss it all together, and boom, you get iced tea, right? That's all you got to do. So, what I have here is I've got 3 beakers with the same quantity of solvent in them. I've got 3 beakers with the same amount of a liquid in them. And what I'm going to do, what I'm going to try to do, if I have one, this is always the worst. I'll use a spoon instead. What I have is I've got some purple drink mix, like, I don't know, grape Kool-Aid or whatever. And so let's try this out. When I say really, really, really concentrated, what does that mean to you? What do I have to do to make something really, really, really concentrated?
Boil it.
Wim, what do I have to do? A lot of the solute to the solvent, right? So we want a really high ratio of solute to solvent. Perfect. So I'll take that. There's my scrupula. That's what I was looking for. And so when I look at this, does that look like the kind of Kool-Aid that you want to drink? Yeah. For some of us, we're like, yeah, hell yeah. Are you kidding me? That would be so good. Super sugary and way too much taste. But that's all right. That's fine. What about a really concentrated. What about a really low concentration? How do I make a low concentration? I'm going to add the tiniest little bit of it. And so let's see. Is this giving us some sort of a Kool-Aid mixture? Yeah, there's definitely Kool-Aid in there. Would you agree?
Yeah.
The water turned a little bit purple, okay? So one of these is very concentrated and one of these is not very concentrated. I'm wondering, what would I have to do to make this into a mixture that you would like? What do I have to do to make this into a drink mixture that you would actually want to drink? What do I have to do to it? I have to add more, but do you want me to add this much to it?
No.
The same amount? Probably not. You want me to add like a medium amount. And then once I add the medium amount, that's going to turn into some sort of a Kool-Aid mixture that's more reasonable, right? This is more of a reasonable mixture. It might still be pretty concentrated. What do I have to do to this in order to turn it into a more reasonable mixture? I have to add more water. I have to add more solvent, right? So I have to take my water and I have to try and add it. And I have to try and add it so much so that it ends up being a little bit more diluted. Are we okay with that? So there's some terms that we've kind of went over so far, and they're really important terms for us to be able to know, and we have to be able to define them, at least in your own words. The amount of solute dissolved in a solvent is called concentration. So we can always represent the concentration of a substance as a ratio for the amount of solute per some amount of solvent. That's what concentration is always. Concentration equals the solute divided by the solvent. Now there's lots of ways of defining this. In a little bit, you're going to have to take out your magic green sheet, and if you don't have one, I'm going to ask here in a little bit, okay? If we have a small amount of solute dissolved in solvent, we refer to that as dilute, right? If that's a tiny amount, we say, oh, that's a pretty dilute mixture, but there's still some in there. If there's a large amount, we refer to it as being concentrated, so there's a lot more solute per solvent. Yeah, Wim.
What would you call a medium?
You could, and that's where these terms concentrated and dilute, they're totally relative, okay? If we were to have a solution that's more in between, we would say the in-between solution is more concentrated than the dilute, but it's more dilute than the concentrated. Do you know what I mean? When I say the word concentrated, I just mean relative to something else. That's all it is. Okay, perfect. So we can calculate concentration in 3 different ways, and we're going to try and burn through these 3 different ways today and tomorrow. We will use 5 methods. There's the percent concentration there's 3 different types of methods, but they're all the same. Then there's parts per million, and then there's molar concentration, sometimes called amount concentration. What I would like you to do is get out your green sheet of paper if you have not already. You should have your green sheet of paper handy. Does anybody not have it, or does anybody need a new copy? Just one person? No, I said I was going to give people the blue copy, right? To try and shame them. Was that it? Even though apparently people like the blue coffee more than the green coffee. So yeah, you're not shamed at all. You're happy to be happy. Okay. In general, concentration is calculated the same way. It's just quantity of solute divided by quantity of solution. Now, there's a bunch of different ways. Does anybody in here know how to calculate a percent? For example, if Mr. Walton was taking a quiz and Mr. Walton got 13 out of 25. Would you be able to calculate his percent for him? Yeah, that's pretty straightforward. What is it? How would I do that? Maddie? 13 out of 25. You take the smaller number divided by the bigger number, right? So the amount you got right out of the total, and then what would you have to do? And then times by 100. So you go 13 divided by 25 times by 100. And so can you take out your calculator and can you go ahead and calculate this? If my math works out correctly, it should be 52, but sometimes it doesn't work out correctly. Hey, does anybody want one of these? Anybody want a calculator? Jenna, can you catch? You can't catch? You're going to have to. You can catch. Anybody else? Cassidy, you got one? You can catch, right? Yep. Sorry, Aaliyah, I almost hit you in the head. Anybody else? Yeah, here we go. You can catch, right?
I can't. Actually,
Oh, okay. Can I catch? Can you throw is the more important question. Yes, I can catch. Okay. So 13 out of 25 times 100, tell me, is that 52? Yeah, that's 52%, right? Okay. You have already finished the first 3 ways of calculating concentration. We're going to go through 5 ways, and all 5 ways, the first 3 are all some sort of a percent concentration. There's something that we call percent volume, so that's volume per volume. There's one called percent mass per volume, so that's mass per volume. And there's one that's mass per mass. But they're just percents. That's all it is. It's so many out of so many. It's pretty straightforward. I have another question for you. This number can be written as a fraction or a ratio. How would I write that number as a ratio? 52 out of what? 100. Percent. Percent is actually 2 words. I know it's 1 word, we say percent, but percent means out of 100. So if you got 52% on a test, that means if the test was 100 questions, you would get 52 out of the 100 questions right. Was the test out of 100 questions? No, it was out of 25. But it's the same scale. It's the same ratio. 52 out of 100 is the same thing as 13 out of 25. When? No. And here's where I just wanted to make sure we all understood that. If you reduced it anymore, you would get 13 out of 25, and we'd be left with the original fraction that we had. Okay, so I just wanted to make sure we understood that they really mean the same thing, right? Okay, so our percent concentrations, there's percent volume, there's percent weight, and then there's weight per volume. Getting the percent, if it's ever asking you, calculate the percent something, you already know how to do that, don't you? It's the percent in milliliters over milliliters, 10 times 100, right? So what this is asking, if this is calculate the percent volume, then you need 2 volumes. Well, we're given 2 volumes, right? Could you calculate the percent of this, right? 94 milliliters of ethanol are found in a 750 milliliter beverage can. So let's calculate the percent of that thing. Go ahead, do that. 94 out of 750 times 100. Somebody give me the actual answer. 12.53. So we're going to get 12.53%. And so this rounded to how many significant digits? 2. So we're going to round it to 13%. Good. And I put the answer here just to make sure that we didn't mess up somewhere. Was that incredibly difficult? No. Okay, maybe for some of us, right? The English part of this is something that's a little bit complicated sometimes. Let's kind of read into it a little bit more. It's saying 94 milliliters of ethanol are found in this much total solution. So that means this thing must have been dissolved in this thing, right? So we're saying 94 out of 750, just the percent. Right? The second example. How much gold is found in a 20-gram ring that is 72.5%? Okay, now what I want to ask you, is it asking for a percent?
No.
Then we will use unit analysis. If it's not asking for a percent, now we're going to use unit analysis to be able to answer this question. Wim, are you going to try and solve the question, or do you have a question about the question? Oh, okay. All right. So it's asking for how much gold is found in a 20-gram ring that is 72.5% gold by weight. Let's talk about this a little bit more. 72.5%. How can I write that so that it's not a percent? You could say 0.725, but I would like to express it as a ratio. Remember, concentrations are always represented as a ratio of the solute per the solvent. Is that okay? So let's talk about this. How can I represent that as a ratio of solute to solvent? Wim? So this really means 72.5 out of 100. But 72.5 what out of 100 what? I want you to look at your green sheet and tell me, what are the units for percent weight? What are the units for percent weight? Does it say grams per 100 grams?
Yeah.
Yes. Okay, so that should mean 72.5 grams per 100 grams. What this means is 72.5 grams of gold, of actual gold, in a 100-gram ring, right? It's solute over solvent. Does anybody have any questions about that? This is the hardest part about being able to solve percent problems, is doing unit analysis and turning this number into a ratio out of 100. So what do we want? What is the question asking us for? How much gold? Where do you find weight of gold anywhere in here? In the top of this, right? So if we wanted to do our unit analysis, we would say, okay, we're looking for the mass in grams of gold. And we're starting with 72.5 grams of gold in 100 grams of our ring. What's the only unit we have to cancel out here? Grams of what? Of ring. And how many grams are in that actual ring? 20 grams in our ring. Now I want to be clear, this is not the only way to solve this problem. You can use ratios, you can rearrange equations. This is the way I would like us to use it. I would like us to do this by using unit analysis. So what you're going to do is you're going to go 72.5 times 20 and then divide it by 100. So hopefully that's 14.5. 14.5 grams of gold. Wim, question? Oh, is the answer, okay. Now, chemists don't ever use percent concentrations. A chemist is never going to use a percent concentration. Percent concentrations are just not good fundamental chemistry. People will use percent concentrations for like real world things. For example, when I go out and I buy my yogurt, I want specifically 2%. So what that means is my yogurt is 2% milk fat and 98% other junk. Does that make sense? But this doesn't have any, other than just the ratio of milk fat per the solution, it doesn't really have any useful information. Not for a chemist. So chemists don't like percent concentrations. They're not the best things in the world. What I would like you to do is I'd like you to try and solve the next two problems. But what I want to bring your attention to is when I say 12.7% weight per volume, what are the units in mass per volume? Look at your green sheet. What are the units for mass per volume? Grams per 100 milliliters, right? So this is really 12.7 grams per 100 milliliters of our solution, right? So just go ahead, try this out. If it's asking for a percent, calculate the percent. If it's asking for something other than the percent, use unit analysis. Just try it out. And I'll be walking around and trying out. Yeah, 42 grams of sugar, that's our solute. 340 milliliters of pulp, that's our solvent. Yeah, no, but it's just saying calculate the concentration in percent. Once we get that percent, we could turn that into something out of 100, but we don't want to do that. It's asking you for a percent. How do you calculate a percent? So it's asking what you're asking us for. How many moles of sodium?
This question was exactly.
We're not going to be able to
Okay.
get the moles of sodium chloride or anything. Do you see anything differences in here? No. I mean, this is a weight per volume. So there's a mass. How do you define mass of sodium? How do you compare mass? What's the weight of the mass?
I got 2.9.
That second question is hard. That second question is really hard to try it out.
How do you do that?
We wanted like in percent.
Yeah, we want. If I asked you to calculate a percent, I got 42 questions right out of 300 questions. How would you calculate a percent?
42 question, right?
Yeah, this is 42 grams out of 340.
So it's 42 over 300.
Yeah. Yeah, just calculating. We're just calculating the percent.
And how we rid of the units?
Okay, we can't because let's just talk about it together, okay? Okay. For the first question, it's saying what is the percent weight per volume? Well, it's asking for a percent. Do you know how to calculate a percent? Yeah. So percent weight per volume is 42 grams of sugar. And what's the total solution volume? 340 milliliters. And we'll just multiply it by 100. Because that's how we calculate a percent. So 42 out of 340 times 100 should be 12 point something. 12.3. But we're going to round it to 2 significant digits, so that's 12%. I need you to really understand that when you're calculating a percent, just go ahead and calculate the percent. It's no different than any other quiz or any other test or any other assignment, right? It's how many out of the total times 100. Okay? The second one is really tough. How many moles of sodium chloride will be in 500 milliliters sample of salt water? That is 12.7%. Let's try this. Do you see moles anywhere in here? Yeah. So, okay. So this is not 500 moles, right? This is 500 milliliters of volume. What are the only places you can get moles from? We can get moles from molar mass. Remember, molar mass converts grams to moles, right? So what we can do is we can look up the molar mass of sodium chloride. What is the molar mass of sodium chloride? 58.44. All we did was we took one sodium and we took one chlorine and we just added them up. So the molar mass is 58.44 grams in every 1 mole. So let's try this out. What do you want from this question? Moles. So we got to put moles of this substance on top. We're looking for the number of moles. 1 mole is 58.44 grams. Now, do you know how much solid, do you know how much mass is in this 500 milliliters? You don't know how much mass is in 500 milliliters, but you do know how much mass is in every 100 milliliters, right? In every 100 milliliters of liquid, how much solid is there? 12.7. So are we going to write this the way it's written right now, or are we going to have to flip it?
That's good.
This is good. Why is it good this way? Grams on the bottom, so we need grams on the top, right? So 12.7 grams for every 100 milliliters. Would you agree, if my solution concentration is 12.7%, what that means is it's 12.7 grams out of 100 milliliters. Do we have 100 milliliters here? We have 500 milliliters. Does that make sense? That's a tricky question. That's a really complicated question. So now all we have to do is just multiply the tops together, multiply the bottoms together, and divide them. And you should get 1.09 moles. I want to be very clear. Every time you're given a percent, rewrite it as a fraction out of 100. Every time it asks you for a percent, that's easy. Just calculate a percent the way you normally would. Okay? There's a couple questions here. I'm going to give you like 2 or 3 minutes just to work on these couple questions while I walk around and try and help some people.
You
did. Not times 2. Because how many CLs? Yes. 1. Are you saying 2 because of Hoffman?
Yeah.
but Hofbrinkel only refers to an element.
Oh, yeah.
Instead of alcohol or gasoline. Gasoline and alcohol. That's not a very good name. Oh.
Isn't your brother sick too?
Any questions? No. Okay. Carry on. 1,000, but as long as both of the units are the same, then we don't care. Yeah. If it's liters over liters, then that's fine. If it was like milliliters over liters, then that would be a problem. But as long as they're the same unit, we don't care. When did you get it?
I got back and I did it all last night. What I don't get divided by 50.
Like fundamentally discussions are not fun. What does that mean? As soon as you add your not
You round it up to 5. Yeah, 0.
Okay, that first question, it's asking for percent volume. So I want to be very clear that if it's asking for percent volume or percent mass, it doesn't matter what the units are as long as the units are the same. The only time you run into problems if you do percent, and then it has to be in grams per milliliter, grams per 100 milliliters. So we've got 4.1 liters of ethanol in a 55-liter tank. This should be pretty darn close to 7% or something. 7.5%. Good. No problem. And then the next one. Solder flux contains 16 grams of zinc chloride in a 50 milliliter solution. Okay, no problem. So what is the percent weight by volume or mass by volume? 16 grams over 50 milliliters times 100%. So we should get 32%, right? Not especially difficult. I hope we're okay with that. Okay, we're going to move on to something called parts per million. Now, parts per million is the exact same thing as a concentration, except concentrations are out of what? Like percent concentrations are out of what? Out of 100. A percent is out of 100. A parts per million is out of a million. That's it. That's the only difference between percent concentrations and parts per million. It's just that you're not used to when I say parts per million. Parts per million is often used for really, really tiny concentrations. So concentrations of toxins or concentrations of pollutants often are represented in parts per million. Sometimes they can be represented in parts per billion or parts per trillion as well. The units for parts per million can either be milligrams per kilogram. I want everybody just to listen up for a second. 1 kilogram of water, do you know how much volume that would occupy? 1 liter of water. So 1 liter of water is the same as 1 kilogram of water. They are totally interchangeable units. Is that okay? But only for water. So we can either say parts per million in milligrams per kilogram, or we can say parts per million in milligrams per liter. What I would like to ask you is, on your magic green sheet, what does it say are the units for parts per million? Milligrams per kilogram. So as long as you know that 1 kilogram of water is 1 liter of water, then you can answer any question really about parts per million. Yes?
If like a milligram of water and then your milliliter of water are equivalent to your of water.
Yes, you can. It's not 1 milligram and 1 milliliter. It's 1 gram and 1 milliliter. Oh, for the top?
Yeah.
No, we're not going to do that. Because 1 milligram of water is 1 nanogram or is 1 nanoliter, and so we're not going to do that. Okay? Just don't worry about that. Don't worry about it. Don't worry about it. The only thing you have to care about, 1 kilogram of water is occupying 1 liter of volume. Okay, let's try this out. So calculate. So 1.334 milligrams of mercury are found in 100 grams of soil. Calculate the concentration of mercury in the soil in parts per million. Now, this is a little bit of a problem because we end up having a little bit of a problem with milligrams and grams and parts per million. You're not used to that. You're used to percents, things like that. So what I want you to think about is I want you to put them in the same unit, and then instead of multiplying by 100, what would you multiply by? You would multiply by 1,000,000. So if you wanted to, you could put them in the same unit, or you could just use unit analysis. Maybe we'll just use unit analysis, okay? So you're looking for parts per million. What are the units for parts per million? Look on your magic green sheet. Milligrams per kilogram. So you want milligrams of your solute divided by kilograms of your solvent. So do you have milligrams of solute? Yes. Okay, that's fine. So 1.334 milligrams of our mercury. Do you have kilograms of the solvent? You have to change it. How many, if I want to do 100 grams of and turn it into kilograms, do you know how many grams are in 1 kilogram? 1,000 grams. So if I want to go from grams to kilograms, I have to divide by 1,000, right? So let's divide this by 1,000. What's 100 grams turned into kilograms? Do we now have milligrams per kilogram? Yes. So we got milligrams per kilogram. Good. Take that, divide it by 0.1. You shouldn't need a calculator, but that's okay. You're dividing by a number less, right? This divided by 0.1 is going to be 13.34.
Yes. Sure.
Parts per million. And then we just have to round to however many significant digits we have. And we've got 3 digits, we've got 4 digits, so we'll take 3 digits. 13.3 parts per million. Okay, let's think about this. What does that mean, 13.3 parts per million mean? That means in every 1,000,000 grams, which is basically like in every million milligrams or whatever, every million grams, there's going to be 13.3 grams of this stuff. Instead of being out of 1,000, or sorry, out of 100, it's out of a million now. That's all. So let's take parts per million, and let's try and kind of change it a little bit. DDT is a pesticide known to damage the shells of some birds. Calculate the concentration in parts per million. So we're looking for parts per million. Sorry, what are the units of parts per million? Milligrams per kilogram. Are we given the solvent as a mass, or are we given it to us as a volume? It's a volume. So what do you want to use? Do you want to use milligrams per kilogram or milligrams per liter? Milligrams per liter. That's all we're looking for. Do you know how many milligrams are in 0.416 grams? We're just going to times 1,000 to get milligrams. So 416 milligrams in 1.5 liters. Should get 280 or 270 something. 277.3 repeating. But how many significant digits do we have? 2. What are my first 2 significant digits? It's got to be 2.8, right? 2.8 times 10 to the 2 parts per million. Does using Uden analysis kind of organize your thoughts, maybe? A little bit. It can be pretty complicated. Yeah, so parts per million again, you got to do milligrams, and it says milliliters, but we probably don't want milliliters, we want liters, right? So you're going to have to change milliliters into liters. And then in the second one, milligrams per kilogram. So then find the parts per million. So go ahead, try it out. 2 questions, use unit analysis. Yeah, milligrams of mercury per 0.1 kilograms of the whole solution. Right? Does that make sense? Yeah, you could say parts per million of mercury if you wanted.
Like stuff that I used to be able to have like 2 of, like like sticking chicken wings. Like the chicken wings. I only ate half of it, which isn't that much. It was like kind of bad, but I go back ways. I kind of don't.
Yeah.
How many? So what do you want to do? You want to go from liters to milliliters? Multiply or if I wanted to go from here, yeah, going from big number to small number, divide by 1. So whatever your number is in milliliters, divide by 5.
Sorry.
Picking up here. Picking up here. Oh, okay. Okay.
Yeah.
So you're not there to drive her home, is that what you're saying?
Yeah.
tough, hey? You don't know what's busted?
I think I'm
Oh. It's easier that way, right?
got 8.8 times 10 to the negative 6. Which means there's no oxygen. Not right. Like near I know. Oh, it's so times I thought it was the
We could have.
must still cook me like maybe I know she used to pick me up too, but now she doesn't pick me up unless I'm like, please. But every time we end up talking, it's like don't do it.
Okay. So, what's the concentration in parts per million? Milligrams per liter. So if we have 2.2 milligrams in 250 milliliters, is that 250,000 liters or 0.25 liters? 0.25 liters. So times 4 should be 8.8 parts per million. Are we okay with that? Yeah. And then in the second question here, if an indoor sample of air with a mass of 0.59 kilograms contains 3.2 milligrams per 0.59 kilograms. This is going to be about 5.42. 5.4 parts per million. Good. Okay. Is that fairly straightforward? Yeah? Okay. Oh man, we got a big decision. We got a decision to be made here. No, we're not. It's either I give you practice problems.
Just move on. Just go.
Don't do it.
Let's just we after this.
What? Well, my goal. I just want to take 1 minute to talk about what my goal is.
Take your time.
Yeah, thanks, Idris. Okay, I would like everybody to focus up on the board. Pretty please, if I'm not bothering you too much. Is that I wanted to get done percent concentrations in parts per million today for sure. That's bare minimum what I wanted to get done. But I also wanted to get done amount concentration because we have a lab coming up on Thursday, or we're trying to get a lab done on Thursday. Now here's the problem. There are lab skills that are required for this lab that you've never done before. You've never used these lab skills because you've never seen these lab skills before. And so what I want to do is I want to take time practicing those lab skills because Thursday is going to be an absolute gong show if you don't have practice using a pipette. Yeah. Yeah, well, if you've ever taken Chem 20 or IB or AP or something, then probably you have, right? Yeah, okay. So, but I want to give you practice using a pipette tomorrow.
Yeah.
So if we quickly, just really quickly, go over molar concentrations, and then I'll give you some practice problems, then we can have lots of time to practice tomorrow in the second half of class. And I don't see any reason why we can't do that right now. So what we're going to do, So what we're going to do is we're going to do two practice problems, or we're going to do two problems, and then I'm going to send you off on your own to do some practice problems for tomorrow. The practice problems have answers on them, and I'm not taking it in for homework. Oh man, I shouldn't have said that, because now you're not going to do anything. But whatever. We'll see. Maybe I'll make you do homework. Okay, amount concentration. This is the concentration you will use for the rest of Chem 20 and Chem 30. Percent concentration is nice. It's okay. People use that in everyday life. Parts per million is nice. People use that in kind of everyday life, whatever. But amount concentration is a concentration you're going to be using for the rest of now. Basically, what amount concentration is it's describing in a beaker of water how many moles for every 1 liter of water do we have of a substance? How many moles of a solute is there? So in here, if each one of these dots represented a mole, we would have 6 moles per 1 liter. So 6 moles in 1 liter, that gives me 6 moles per liter. Now, this is important because all of a sudden, moles, what do moles describe? Yeah, we can convert between moles and grams using the molar mass, right? But moles, what is moles short for really? Molecules. It's short for the number of molecules in a substance. Does that sound more like chemistry to you? Describing the number of molecules in a given substance? That's a lot more chemistry, and that's going to be more useful later on. So, all you need to know is that molar concentration or amount concentration is measured in moles per liter. So we'll take the moles divided by the number of liters. If you don't have the moles and you're given the mass, how can we convert between moles and mass? Molar mass. So every once in a while we might have to calculate the molar mass of something. 0.532 moles of potassium nitrate are dissolved in 0.250 liters of water. What is the amount concentration? What's amount concentration measured in? Moles per liter. 0.532 moles in 0.250 liters. You should get 2. Does it round up to 2.13?
Yes.
Yeah. 2.13 moles per liter. That's really all it means. So in every 1 liter, we have 2.13 moles. We don't have 1 liter, we have 1/4 of a liter. So we'll have 1/4 of the number of moles. But it's the same ratio. It's describing the same amount. What amount concentration, how many moles of sodium hydrogen carbonate is needed to make a 150 milliliter solution with a concentration of 3.2 moles per liter? That's a lot of information. What are we looking for? You want what amount or how many moles? Do you see moles in here at all?
Yeah.
Yes. So I'm looking for the number of moles. I can get moles as long as I cancel out what unit? Are you given liters? Kind of. You're given milliliters, right? So what I would suggest is turn this into liters. 0.150 liters. And hopefully you should get 0.480 moles.
Yeah.
Any questions about that? What are you confused about? Okay, you didn't get the 0 on the end,
Yes.
and that's a good question to ask. Okay? If you put this into your calculator, you're going to get 0.48, correct? Yep. But we need how many significant digits? 3. So what do you know about the next digit? It's a 0. What's the next digit after that? It's a 0. What's the next digit after that? It's a 0. It's a 0 and a 0 and a 0 and a 0 and a 0. It's just that your calculator's not showing it. So we'll take the 3 significant digits and we'll report those 3 significant digits. Is that okay? Yeah. Amount concentration. Yeah, you should be able to do those questions.